Good morning, students. We are dealing with the topic solution. In that solution topic, we are dealing with now the topic colligative property. Colligative property. There are the main four colligative properties. Colligative means collected together. There are the main four colligative properties. First colligative property is the lowering of the vapor pressure. Second is the elevation in the boiling point, depression in the freezing point, and fourth one is the osmosis. These four properties we can see for one by one. Now, first is the Raoult's law of non-volatile solute. We can see in this chapter, we can see also the Raoult's law for quantitative relationship between vapor pressure of the solution and solvent. Now, next is the Raoult's law for solution of non-volatile solute. We can see in the Raoult's law that in the solution of non-volatile solute, the law is applicable only to the volatile solvent. And this law, Raoult's law for non-volatile solute, states that the vapor pressure of solvent over the solution is equal to the vapor pressure of pure solvent multiplied by its mole fraction. And this law we can mathematically be written as P1 is equal to P01 X1. And this is the graph for the variation of vapor pressure of the solution with the mole fraction of the solvent. The graph is vapor pressure of the solvent against the mole fraction of the solvent. For a binary solution containing one solute, X1 means mole fraction X1 is equal to 1 minus X2. We know that X1 plus X2 is equal to 1. So, X1 is equal to 1 minus X2. Therefore, the Raoult's law, it follows that P1 is equal to P01 X1. If we can multiply this equation, this X1, we can replace the value of X1 is equal to X2. That is equal to P01 1 minus X2, and multiplied this equation we get P01 minus P01 X2, or we can also write this equation as P01 minus P1 is equal to P01 X2. Equation 2.5 defines the P01 minus P1 or delta P. P01 minus P1 is nothing but the delta P, means lowering of the vapor pressure, means delta P is equal to P01 X2. This is the equation number 2.6. This equation, what we show the equation? Equation shows that the delta P means what? Lowering of the vapor pressure depends upon the mole fraction, means lowering of the vapor pressure depends upon the factor X2, that is on the number of solute particles. Thus, delta P means lowering of the vapor pressure is a colligative property, means here the relative lowering is depend upon the delta P, and so lowering of the vapor pressure we can say that it is a colligative property. Now next is the relative lowering of the vapor pressure. What is the relative lowering of the vapor pressure? It is nothing but the ratio of vapor pressure lowering of solvent divided by the vapor pressure of pure solvent is called as the relative lowering of the vapor pressure. Delta P means relative lowering of the vapor pressure. We can given by delta P is equal to P01 minus P1 divided by P01. This equation 2.6 means, what is the equation 2.6? That delta P is equal to P01 X2. This equation we can written in this way, that delta P divided by P01 means dividing this equation by P01 is equal to x2 is equal to P01 minus P1 divided by P01. Thus, the relative lowering of the vapor pressure is equal to mole fraction. Which is the mole fraction? X2. Thus, the relative lowering of the vapor pressure is equal to mole fraction of solute into the solution. Therefore, relative lowering of the vapor pressure, it is the colligative property. X2 means in this both of this equation, what we find that the relative lowering of the vapor pressure, it is a colligative property and it is depend upon the mole fraction. Next colligative property is the molar mass of the solute and vapor pressure lowering. We have studied that the we have studied that the relative lowering of the vapor pressure is equal to mole fraction. We studied this now. That is the relative lowering of the vapor pressure. It is depend upon the x2 of the solute in the solution. From equation 2.6, it follows that delta P divided by P01 is nothing but the x2. We know that mole fraction x2, it is depend upon the two factor, that number of the moles of the solute plus number of the moles of the solvent. Means the mole fraction of the component is equal to its mole divided by total numbers of the moles into the solution. Here N1 and N2 are the moles of the solvent and solute. Means N1 is the moles of the solvent and N2 are the moles of the solute respectively into the solution. We can concern only with the dilute solution. If we take only a dilute solution here, hence here N1 is greater than N2. And N1 is greater than N2. N1 is more greater than N2, and N1 plus N2 is nearly equal to 1. Means what? The value of N2 means moles of the solute which are dissolved into the solvent is negligible. Means N1 is nearly equal to N2. The mole fraction X2 is then given by X2 is equal to N2 divided by N1, and X2 is nothing but what? X2 is nothing but the delta P divided by P01 from equation number 2.8 is nothing but the N2 divided by N1. Means X2, we have comparing these two. Delta P divided by P01 is nothing but the N2 divided by N1. It is nothing but the X2. Suppose that we have prepared a solution by dissolving Y, means W2 gram of the solute in W1 gram of the solvent. The moles of solute and solvent into the solution are then, means if we take the W2 gram of the solute and W1 is the solvent, and we dissolve to the W2 into the W1, then this equation can be written as N2. N2 is the numbers of the moles of the solute. N2 is nothing but the W2 divided by M2, and N1 is nothing but the W1 divided by M1. Where what is M1 and M2 are the molar mass of the solvent, and where M1 and M2 are the molar mass of solvent and solute respectively. Means M1 is the molar mass of the solvent and M2 is the molar mass of the solute. Substituting this equation, means comparing equation 2.10 and 2.9, we get that X2 is equal to delta P0 divided by P01, which is nothing but the N2 divided by N1, means W2 divided by M2 total divided by W1 divided by M1, means delta P01 minus P1 is divided by P01 is nothing but the delta P. We know that is divided by P01. That is equal to W2 into M1 divided by M2 into W1. This is the equation 2.11. Knowing all these quantities, molar mass of the solute M can be calculated. We have seen in this now the derivation of molar mass of solute and vapor pressure lowering. Next is the boiling point elevation and concentration of the solute. Boiling point elevation. Elevation means increment, increase in the boiling point. Boiling point elevation and concentration of the solute. What is the relationship between boiling point elevation, means increase in the boiling point, and solute concentration? The boiling point elevation is directly proportional to the molarity of the solution. Elevation in boiling point is nothing but the delta Tb. It is directly proportional to the molarity, means Em. Elevation in the boiling point means delta Tb. It is directly proportional to the molarity in the solution. Or we can, if we have to remove the directly proportional to the sign, we have taken that delta Tb is nothing but the is equal to Kb into M. What is the M? M is the molarity of the solution, and Kb it is called as the proportionality constant, or it is also called as the ebullioscopic constant, or it is also called as the molar elevation constant. If we take, suppose if M is equal to 1 and delta Tb is equal to Kb. If M is equal to 1 and delta Tb is equal to Kb, then ebullioscopic constant is the boiling point elevation produced by a 1 molar solution. So what is the unit of Kb? Kb is equal to delta Tb divided by M. Delta Tb means boiling point elevation divided by molarity of the solution. Means the boiling point, what is the unit of boiling point? It is temperature, which is measured in a Kelvin, and mass is mole, kilogram raised to -1. This is the unit of Kb. Kb means ebullioscopic constant has unit Kelvin, kilogram, mole raised to -1. Next, second colligative property is the boiling point elevation as a consequence of the vapor pressure lowering. To understand the elevation in the boiling point, let us compare the vapor pressure of the solution and those of the pure solvent. We can see in the graph what we see. There is the, on x-axis there is a vapor pressure, on y-axis there is a temperature. We can see that the graph of A and B is which is the graph of the solvent, and graph of C and D, it is the graph of the solution. The vapor pressure of solution of pure solvent are plotted as the function of temperature. Means vapor pressure, the graph is against a vapor pressure and temperature. We can see the graph. As the surface of the temperature and vapor pressure of the solution is lower than that of the pure solvent, we can see the graph that solvent has the higher temperature and solution has the lower temperature. Means vapor pressure of the solution is lower than the vapor pressure of the solvent. Vapor pressure temperature curve of solution CD, which is lies, we can see the graph CD curve is lies below the solvent AB. Thus difference between the two vapor pressure increases as the temperature and vapor pressure increases as predicted by the equation. Means delta P is equal to x2 minus P01. The intersection of the curve CD with the line correspond to 760 mm in the boiling point of the solution. The similar intersection of the curve AB in the boiling point of pure solvent. It is clear from the figure that the boiling point TB of the solution, we can see the graph TB.